right. Thanks, Jim. Pleasure to be here. So I'm going to do something different, I guess. I'm not going to talk about one project or delve deeply into any bit of my own research. I'm just going to talk about some papers that I really liked, and maybe give kind of a framing of these papers as part of a typology of experiments people can run. The reason I think that's kind of useful is I think we're all networks people and we like patterns. And so thinking about network experiments as a series of patterns may be useful. And the examples I'm going to give are not in health, so I'm not a health researcher. But hopefully some of these ideas may be useful in your own work. Field experiment, 2 words. I think the field part is real people. The network intervention stuff that was presented right before this is really inspiring. As a graduate student, I was very inspired by this work. It's just very cool. It's always cool. As a field researcher myself, there's nothing more invigorating than being out in the field with real people. It's by far the coolest part of the field experiment phrase, field part. Real people, real meaningful outcomes for them, and hopefully for society. And then the experiment part, I've been thinking about why I got into doing experiments. I think as a graduate student, I realized people want to answer causal questions. I mean, that's why we're in science, either to describe or to make causal statements about X causing Y. That way we understand the way the world works. I realized I was not good enough to do this with observational data. And that there was no way I was going to write some likelihood function that was going to solve this problem with observational. So I thought, hey, what's easier than flipping a coin? I'll flip coins. That's for a living. So randomization into conditions done by experimenter or naturally in a field setting. And this is to basically get at more causality than you would be in other contexts. And so there are hundreds of questions that we can try to answer about networks using field experiments. I'm going to try to talk about papers that do 4 types of these. Peer effects, talked about a little bit in this context. Does person J influence the behavior or outcomes of person I? Lots of different ways that this can be done. Network formation. In fact, actually, this area has been probably experimented on the least. And we actually have a set of very early facts. This is the stuff by Thomas Allen at MIT on propinquity, and then a series of other studies on propinquity. But what affects whether I forms a network with J? Can we design networks? Which network structures maximize network level outcomes? So some studies that were discussed about villages and camps and the diffusion. So how do you leverage that information to actually design interventions? And then using the information inside networks to make policy choices. So that's what I'm going to be talking about in terms of papers. Let's talk about peer effects. Before I do that, I just want to frame the inference problem for field experiments or just networks in general, and just understanding the basic dyadic influence process. Sometimes we're interested in kind of Alice, A affecting B, influencing B. And we can basically run a model. I'm sorry, this is all the way at the bottom, looking at the outcomes of Bob as a function of the characteristics of Alice. You have, let's say in the educational context, grades. How does Alice's academic background or experience affect Bob's? So you might run a regression of the form y equals beta 0 plus beta 1 times Alice's score plus epsilon. And the problem is that it's really hard to tell whether this is causal or not. There's lots of different reasons why we may not believe that this is a network effect. So there's a reflection problem. The regression specifies the influence of A on B, but we may be actually picking up the influence of B on A. Can't tell these two apart. So important to figure that out. Selection. Similar people are more likely to interact. If Alice and Bob are both really, really smart, and they decide to interact with each other and form a tie, you're not really measuring the influence of one on the other. You're just measuring the fact that smart people like interacting with each other. So we're picking up homophily, not influence. There may be common shocks. People who are interacting have common contexts and common experiences. So maybe Alice and Bob are actually in a group of friends together, and their friends are actually making both of them better, and they're not observed in the regression. Or they have a great teacher that may be teaching them tons of interesting stuff that may make them both smart, and we're not understanding the effect of A on B. So what we might be picking up is the effect of common experiences, maybe noisy hallways, extra coffee on the dorm floor, good teachers, all of these things. In essence, we have no idea what the heck is going on, right? And as a result, we can't really make policy recommendations based on this analysis. We don't know what we're picking up. And so in a sense, this changes what we can say theoretically, but we can also say practically about what policymakers can do. So in essence, there's an imbalance between the treatment and control groups because there's some external factor that may be causing this correlation that has nothing to do with the network effect. And so the identification problem, if we think about it just visually, is actually an uncertainty problem. It's a problem about how much of beta 1, the effect of A on B, is actually the effect that you care about. Can I identify the effect? That's all identification is. Is it all peer influence? Is it entirely something else? Or is it somewhere in between? And this uncertainty about the extent to which you're saying something about the thing you care about causes a real problem. So how do we deal with it? Simple ways to deal with a reflection: just lag the independent variable. Use Alice's grades or scores before she ever met Bob. Easy. Easier. Selection. You could include controls that account for dimensions on which people may decide to form a connection. But as we all know, there's lots of reasons why idiosyncratic reasons why people might want to be with each other that the researcher just never will be able to observe. And then common shocks include characteristics, controls, for the context that may influence the performance of both A and B. So basically, the model then changes to Y. Now it has got a time index to it because of the lagging. Beta 0 plus beta 1 lagged. If anyone wants these slides, I'm happy to share them as a function of all these controls. Now, this could still be problematic because there is an infinite possibility of other things that may be going on that, as researchers, we just can't observe. And so how many other factors can you actually account for in your controls, especially with small sample sizes like the ones we work with? So why do you have randomization? It creates balance between the treatment and control groups. All that means is that basically it breaks the correlation between the characteristics of the treatment and the person being treated, right? And in the network context, the treatment is always another person or some part of the network structure. And the worry, for instance, is that the treatment, being in a network structure, maybe connected to this person, is correlated with your unobservables. It reduces the likelihood that unobserved factors of selection, it doesn't eliminate it, but in expectation, it reduces it. It reduces the probability of it. There's nothing ever that randomization solves perfectly. But you know that in expectation, basically there should be zero correlation. So it reduces the likelihood that unobserved factors of selection or context are causing these effects. Now imagine if I flip a coin and I say you're in, you're out, you're in, you're out, you're in, you're out. That coin flip, 1 or 0, heads or tails, should be completely uncorrelated with anything about you, right? Who your friends are, who your parents are, what you ate for breakfast today, your thought last night about how, what you're going to wear to this session is completely uncorrelated to, because only thing that's correlated to it is the physics of that flipping of a coin. And that means I can basically ignore all those other factors. And that ignorability is the power of randomization. In the end, this is because the treatment condition, whether you're connected to that person or not, in this case, and the characteristics of the pairs are now completely uncorrelated because of this ignorability that comes from the mechanism through which you are assigned the treatment, that flip of the coin that has nothing to do except for the flip of the coin. Okay, so I think one of the coolest papers on this is a paper by Bruce Sacerdote at Dartmouth, where this paper I read as a graduate student, and I thought, wow, he basically gave us a framework to really think about how do we actually estimate network effects. So he studies Dartmouth students, and there was an interesting quirk that for many years, probably still happening today, maybe not less so, Dartmouth students were completely randomly assigned to dormitory rooms conditional on gender. And that means that there's no correlation between any characteristics of the roommates and their backgrounds. Now, you can run a regression where you look at the high school grades of your roommate and see whether it has an effect on your academic performance. Interestingly, that effect was basically very, very tiny. He found other effects, basically whether you decided to join a fraternity, other social dimensions, where your roommate's choices, interesting, those factors still have the reverse causality problem because of reflection, because the choice you make to join a fraternity is occurring at the same time as your roommate's choice, and so there may be kind of who affects whom is still entangled. But it gave you a very, very clear framework. You randomly assign roommates, and then you can look at the roommates' pre-treatment characteristics before they ever interacted with each other on your future outcomes. He actually found that there was no evidence for a causal peer effect, and there was actually kind of a cottage industry of randomized roommate studies in economics, which in expectation found very little effect of network characteristic peer influence on academic performance. And so that was really, I think, a little bit shocking for me because I was raised in an environment, my advisor was a network scholar where networks affect everything, they're everywhere. And I'm like, oh my God, when you actually have a clean design, there's no effect of the network. What the heck? And so it was like, a real motivating thing for me to think about, okay, well, can we actually do the Sacerdote study better? So what I did, here's a paper I wrote, it's in the ASR, with actually better data than Sacerdote. With random assignment, we went in, actually randomized roommates working with the university, and then we also measured social networks, something that they didn't measure. They just had randomized roommates. And so what we were really trying to figure out is why aren't these studies actually finding any effects? And what we found is that a couple of other things. They had dependent variable problems. Everyone was in a different major. Lots of, there's how much variation is there even in people's SAT scores when they go to Dartmouth? I would imagine it's very little. So we got lots and lots of variation, and then everyone took the same exams at the end of the term because in India, everyone takes the same exams. So you actually have very, very consistent measures, and then you find actually pretty strikingly large peer effects, even with the same design as Sacerdote. But what's also most interesting in this is that we found that basically friends have no influence on your academic performance because we measured who people connected to. What we found out was essentially the people that you study with regularly, they're the ones that influence you. And some more interesting stuff, we had data for 4 years afterwards, so we could actually track the dynamics of whether people formed a tie with their roommate, how long the roommate ended up having an effect. And what we found is if you get, so remember these peer effects are bidirectional. You can have a crappy roommate, your performance declines. You can have a good roommate and your performance increases. And what we found in this paper is that there's a lot of selection going on. If you get assigned a crappy roommate in the first year that isn't really academically oriented, your performance does drop. But you don't study with them after the first year. And so their effect declines over time. On the other hand, if you get assigned to a really smart roommate that boosts your performance, you continue to have that performance boost over time. And so people aren't automatons. They're like, you're bad for me. I don't want to talk to you anymore. Whereas I'm actually getting great performance benefits. And so there's a selection going on that we can observe because of this randomized shock over time. And so this network experiment allowed us to both get treatment effects, but also selection effects, right? There's adding and dropping of ties over time. People have done this in lots of other contexts. Now, in my context, where we randomize people that didn't know each other, people often use big networks where network structures already exist. So there's a very famous, now infamous experiment where people on Facebook were sent messages about going out to vote. And they found that the people that were randomized messages to say, hey, go out and vote, went out and voted. That's not interesting. There's nothing networky about it. But what's interesting is that the people that they were connected to were also more likely to go out and vote. Obviously, this has led to lots and lots of problems of election manipulation and everything. But here's another network experiment. The network exists. How do you use it? You leverage it as an existing structure and then randomize information across that structure. Here's another one. A very, very similar structure to it. A network exists. You have online friends. You're connected to them. You give a free product to one of those people, are you more likely to buy that product? I once heard Chuck Mansky at a conference, one of the kind of econometricians who framed the network inference problem very early on, said something really interesting. He said, it's so interesting that a lot of people are using all of this exciting econometrics and technology to get people to click on ads. So, all right, so here's another experiment that I did. Where we took it out of the educational context. So this is 100 high-growth technology startups with venture capital funding, and we were trying to understand how much of the knowledge that's associated with building a business is coming from social relationships, tacit knowledge, kind of a Polanyi kind of idea of tacit knowledge affecting businesses. And so what we did is we basically created our own little boot camp with 100 startups, and we randomized them to get advice from other businesses. And these businesses had pre-existing practices inside their firm. Did they talk to their employees regularly? Did they set goals? And we measured this before the intervention. And then we randomized them. And what we found is that the people who got advice randomly from a randomized peer who had formal management practices in their organization adopted those practices, and then we tracked their outcomes over 2 years. They grew 28% larger and were 10% less likely to die. So it's the same exact framework as the peer academic study, but with businesses, and 3 of these companies are billion-dollar businesses now. It's pretty exciting. We had everything to do with it. All right, network formation. How do you form a tie with somebody else? So lots of papers here. Here's a cool paper that I really liked where they looked like at an online dating site, and they found out that basically if you made visible for certain people, so there's a whole bunch of people on a dating site, and if my browsing history, all the profiles that I'm clicking on and looking at is visible to others, like that they can see that I'm seeing their site or their page, I'm actually not likely to search. And I'm also not able to send a signal to the person that I'm clicking on that I may be interested in them. So what they did is they randomized who was in the condition where their search behavior was visible to the people who were being searched. And they found out that the people who had these one-way mirrors, they could browse and no one would know that they're browsing, actually ended up getting less dates than people who whose search behavior was actually visible, because people got a signal that they were interested in them, and so that led to more network formation there. So I thought it was kind of a cool, clever intervention. Another really cool one done at Harvard Medical School was looking at, basically got scientists like this in a room together to share their research. And what they found out was most scientists who worked on the same topic, even at Harvard, didn't know the other person existed. And when you put them into a room together, they were more likely to write grants together and write papers together in the future. So there's a search friction. People who could benefit from interacting with each other don't even know they exist. And this randomized shocks could just basically provide awareness of people that allow them to form this connection. And the outcomes aren't like qualitative, like, oh, how do you feel about this person's research? It's basically, did you apply for a grant? Did you end up writing papers together that were measurable like in concrete terms? I have another paper that basically shows, this is in management science, where we actually can look at not just the first order, do people who get put into the same room together form a tie, but whether people, what's your name? Angel. I connect to Angel randomly, but that's not what I'm interested in. I know that's going to happen because we're in the same room together, but the fact that triadic closure unfolds over time and that now people in Angel's network are now part of my network and that those connections are durable. And what we find is that this first order connection happens, but most interestingly, that my network begins to change. So I get connected to Angel, and Angel is a person who's at a very distant part of the network. Basically, I end up becoming a bridge connecting them, myself, to other parts of the network. And this raises a really interesting question about peer effects, right? We've been basically, what's Angel's effect on me, right? But actually, now I'm showing that it's just not Angel that I'm connecting with, it's actually Angel's network. And so is it Angel that's affecting me or his broader network that's affecting me? And that opens up from this observation of this dynamic formation of networks over time. What we also found in another series of studies is basically, okay, we believe that people that are in the same room together, they form a network. It does happen, but 90% of randomized interactions never produce a network tie. And we've shown this in a variety of data sets. And what that means is that people exercise a tremendous amount of agency over who they're connecting with. And that poses a fascinating challenge for network interventions. Because if 90% of the time what you're doing is not going to matter, that means your effects may be really small. And so you have to be really thoughtful in how you leverage the network information. Jim, how much time do I have? Okay. Huh? I'm 4 minutes. Okay, 5 minutes. I'll take 5 minutes. I don't have much more. So, okay. Let me skip this because that's a lab experiment. So another cool paper was done in Malawi. This paper just published last year, and it's really cool. So they go around, they have this farming technology, and they want to increase this diffusion. It's very easy to adopt, but it's not being adopted. So they go to about 200 villages in Malawi, and they measure their networks before any intervention is done. And then what they do is they use ideas from network theory, so things like traditional diffusion models, or the Centola-like diffusion from kind of multiple angles. Influencers. I don't know the. Now I'm blanking on the term, but lots of using like the chieftain or using the person with the highest degree centrality or the person with the highest brokerage to assign the interventions, who to seed in the network, and they basically simulate this out and figure out, okay, which different network theories predict different injection points of this farming technology in the network. And so they basically do a randomized control trial where they try these different seeding methods, and they find actually that diffusion differs dramatically depending on what targeting technology that you, targeting mechanism you use. In their case, they found that the targeting from multiple angles, the Centola model worked the best, but not in all networks. And so another example of like a network experiment that's interesting. Another cool experiment was done at the US Military Academy, where they said, okay, we can find out who is having peer effects. Can we optimally design how to design the network so that maximum diffusion happens? And they found out once you do that, basically people think they're being manipulated and they don't interact with anyone that you assign them to. So, that endogenous creation of like backing out of the experiment is also really interesting. Okay, last one. Last paper just published earlier last year. They go into villages in India and are trying to figure out who to give money to as entrepreneurs to help them scale their business. And they have a whole bunch of like different things, how well your business has been doing in the past, et cetera, et cetera, et cetera. Whether you have education, what type of business it is, none of those things affect the rate of return on the investment into that business. But they found out that if you use community information, so information from within the network, other people in the community, and so they have an experiment, I won't go into the details of it, but it's beautiful, where the community is asked, who would you invest money in? What do you think the predicted rate of return is for your venture versus your venture, and then aggregate it, kind of like a wisdom of the crowds kind of thing. Basically, you can increase the rate of return by 4x, going from an average rate of return with no information to using network information. You get somewhere between 3x, 24 to 30% per month rate of return on the amount invested if you use network information. So I think there's a lot of exciting models out there of how people have used network interventions to solve real problems. And I think there's lots of opportunity to even build on these and answer deeper questions that may be relevant to your line of research. Thank you.